defining if a relation is linear or if it's a function. So the definition of something that is linear means that it has a constant rate of change. That is the answer to any question. Whether it's an equation, a graph, or a table, doesn't matter. You simply state it is linear because it has a constant rate of change. And if it doesn't have a constant rate of change, you just put it doesn't have a constant rate of change. That is the sentence. If you would like to be more specific, you can talk about an equation or you could talk about a graph. But you do not have to use these different definitions, but you can if you like. If it's an equation and you know it's linear, you simply state it can be written as y equals mx plus b. Now, when you're evaluating an equation, you might go down a list of rules, like the variables can't have any powers, the variables can't be in the denominators, the variables cannot be multiplying each other, or there cannot be any special grouping symbols like square root signs or absolute value bars around the variable. Anything that's being done to the variable would break one of those rules. But you're not allowed to say, this equation is not linear because it breaks a rule. That's too vague. Let's take a look at some examples. Is this graph linear? The answer to that is yes. And if I ask you to explain, you should say, because it has a constant rate of change. Period. You're done. If you would like, you could also say, because it is a straight line. How about this graph? Is this linear? No. What's the reason? It does not have a constant rate of change. How about this one? Yes. What's the reason? It has a constant rate of change. Let's take a look at a different type. Is this equation linear? Yes. Explain why? Because it has a constant rate of change. That's it. It's the same answer every time. You could also say, because it can be written in y equals mx plus b form. But the phrase, it has a constant rate of change, works as well. How about this? Is this equation linear? No. Why not? It cannot be written as y equals mx plus b. Or it does not have a constant rate of change. It's the same answer every time. How about this? Is it linear? Yes. Explain why? It has a constant rate of change. Is this linear? No. Explain why? It cannot be written as y equals mx plus b. It does not have a constant rate of change. How about this table? Plus 1, plus 1, plus 1, plus 2, plus 4, 3, plus 4? No. Explain why? It does not have a constant rate of change. Let's take a look at the other definition. How do you define if something is a function? Well, you simply state every input has only one output. Every input has only one output. It works for an equation, it works for a table, it works for a graph. That's the only sentence you need to remember. If you would like, you could describe the table as having no repeating x values with different y values, but if you leave this off and just say it has no repeating x values, you're going to get it marked wrong. If it's a graph, you could also use this phrase. It passes the vertical line test, which is how we check for repeating x values. Let's take a look at some examples. Is this a function? Well, let's look at all of the inputs. Nothing repeats, and every input has only one output. Yes. Explain why? Every input has only one output. Every input has only one output. How about this one? No, this is not a function. Explain why. Every input does not have only one output. Let's take a look at a graph. Is this a function? Yes. How do we know that? Because every input has only one output. Same answer. Is this function a graph? Yes, because every input has only one output. Now, if you're not sure how I'm saying yes or no, then you can use the vertical line test. You're looking to see if you ever touch the graph twice at the same time, which we don't. So that's a yes, because it passes the vertical line test. Same as this graph here. When I draw my vertical line, I never touch the graph more than one time. So this is a function because it passes the vertical line test. Now take a look here. I touch the graph in two places. So this is not a function. And we say because it fails the vertical line test. It fails the vertical line test. And that is how you define linear or functions.